I'm going to share 4 nice examples of how we turned real offshore challenges into nice offshore solutions. Some of these solutions may resonate with the problems that you might be facing or the whole industry is facing altogether. But before we dive into these 4 practical solutions, it's important to take a few steps back and actually ask the question why innovation matters in the first place. The first key driver is that the projects we see offshore are becoming much bigger and bigger turbines, therefore bigger foundations. Projects are moving further offshore, greater water depths. And I don't know from experience, but you may know that 10, 50 years ago, the projects we're working on today would always be unimaginable 15 to 20 years ago. But even though these projects are getting bigger and bigger, we're still having the same targets, and that is improving safety, driving efficiency, and altogether supporting the industry and making the offshore wind sector more competitive. Interesting to mention as well is the cross-pollination from oil and gas. That sector has been facing challenges for over decades and been solving those challenges with practical offshore solutions. And all that knowledge is slowly being transferred into the offshore wind sector. And the quote at the bottom, the future of offshore wind will require safer, smarter and more efficient ways of working. And within OEG we are working to reach that target. The OEG approach, first of all, innovation starts with a real operational challenge. It's never a brainstorm session or a marketing campaign. It's a real challenge that either a client is facing, a partner is facing, or the wider industry is facing. So it's identifying that problem, then developing a tool that fixes this solution, then validating the system, deploying it offshore, and then potentially the most important part is improving the system, because the first system is never the last. The first version is never the last version. So solving offshore challenges together, what we've learned over the years is that the best ideas don't come from working in isolation. The best ideas come from working together and collaborating on certain problems. So clients come with requirements, operational requirements, our engineers come with technical expertise, and our offshore personnel come with the real offshore knowledge and etc. Many of the challenges that we are facing in offshore wind today are challenges that we face across the whole industry. Whether that's related to safety, access to certain areas, or efficiency and cost, but we face the same problems. Interesting one is that progress starts, I really like this quote, where we focus on solutions rather than constraints. People are always easy to say that it can't be done or things are impossible to do, but the real interesting conversations start when people ask the question, how could we do it and how can we do it? And that's exactly the mentality that we have within OEG. Here you see the innovation in practice. So these are the 4 solutions that I'd like to present today. 4 different challenges and 4 totally different solutions. Different maturity stages, I must say. The top left, maybe the most well-known version, the ICCP-SEM, is currently being deployed, and I'll share some more information on that later, whereas the Revolution is still in the development phase. So the Mecanum crawler is a tool that is developed based on the Mecanum principle for the weld inspections on critical welds, on the nodes of the jackets, and also other tubular connections. You can see here that there were 3 versions. So the first version, the first draft, was the arthropod. As you can see, it is the space and the flexibility of the tool is quite limited. It's a very big tool. Then the Gobi-SOX was already a great step ahead. And now we see the Mecanum crawler, which is a much smaller and lighter version, which we use to deploy to do the critical welds on jackets. And now we're also able to do this on monopiles as well. So the system has 4 thrusters in it, and it sticks itself to the member or to the monopile. And then it can, with the Mecanum, the omnidirectional wheels, based on the Mecanum principle, it's able to maneuver up and down the beam and do the weld inspection with ACM with millimeter precision. So the goal here was to eliminate the need for diver intervention. Usually this would have been done by a diver. There's no way to go down with an ROV and millimeter precisely scan this weld, but with this tool we can. So that's not only a safety upgrade, but it's also an upgrade on cost, because a diving intervention is just much more expensive than ROV. The next one is the marine growth sampling tool, which is developed in collaboration with the Wageningen Marine Research University. It's a tool that combines our offshore knowledge and expertise together with their ecological expertise. So the tool was developed to hang under one of our existing ROVs and scrape off the marine growth so we can sample it later. But you have a lot of constraints when doing this. You don't want to damage your coating on the monopile, so we had to sit down together and combine our knowledge and expertise to develop this tool. Since its development, it has already done 22 successful samples offshore. And here again, the traditional way would have been done by divers, which is very expensive. And now to make it cheaper, we can do more research and we can find more. Then Revolution, which is an interesting one. We own a fleet of over 20 ROVs from the Subsea, so probably the most familiar one for you as well. We had a lot of challenges, like the traditional system is not being developed or supported by Subsea anymore, so we needed to develop our own system. Older systems, they don't have the station keeping capability, so sort of dynamic positioning you could say, and there's no suitable retrofit solution available. So we're relying on old software, old data. So what we did is start our own software solution. It's called Revolution, where we have a new control architecture, built-in dynamic positioning using this tool underneath the ROV, which means even the lightest class ROV like a Tiger can maneuver much more efficiently and is much more stable in the water. Enhanced diagnostics and a fleet-wide retrofit capability, which also means that in the future we will be able to develop our own ROV systems instead of being reliant on Subsea with very long lead times, etc., etc. So yeah, it's a future-ready control platform for a proven ROV fleet. So the ROV fleet is already proven, but we're only making it better. And then the most well-known solution is the ICCP SEM that we've developed in close collaboration with our partners from Corrosion at the back. Thank you very much, Niels. So it's a tool that was originally developed for new ocean conditions in the Baltic Sea, low salinity, deeper monopiles, bigger monopiles. You need more protection, and with the traditional method that was hard to comply with, and therefore we sat down together with Corrosion to develop this tool. And as you can see here, I think if I click forward, you can't see it. This was the first draft version in 2022, I believe, so only 4 years ago. And now we're currently deploying it offshore on the wind anchor project. The challenge was larger XXL monopiles requiring more corrosion, external anodes on higher altitudes were more vulnerable to impact, for example CTVs, and reducing offshore exposure during installation. So with this tool we are off the critical path, which is very positive for the big tier 1 T&I installation contractors. Our approach is installing it from the inside of the monopile, so as you can see it's a circular version, which we can lower down through the manhole, through the hatch, and install these anodes from inside of the monopile. Deeper installation, that's one of the key benefits, to lower altitudes, and it's a diverless reversible installation methodology, which means in case of a remedial we can go down with the ICCP tool again and reconnect the anode and put a new one in place instead of using the traditional diving method, like I said before, which is a very heavy expenditure. So it's rethinking cathodic protection for modern offshore wind foundations. Of course, the challenge that comes with developing new tools and innovation is getting the security and getting the confidence and from the market that they trust, so that building the trust with the market for your new development. As you can see, we've signed 3 contracts now. The first one is wind anchor, where we're going to do 21 monopiles and install 7 anodes on each monopile. Then Q4 2026 we're going to do the 2 substations for Baltic Power, where we're going to install 6 anodes on both the foundations. And then Q1 2027, which is the biggest contract for Baltic 2 and 3, signed with Equinor for 100 monopiles with 4 anodes each. And then here are some pictures of the first offshore installation campaign we're doing for wind anchor at the moment. So here you can see real underwater footage of the tool actually hanging out of the elliptical prefabricated hole inside the monopile, proven that the technology actually works. Coming back to my title, getting it from the drawing board and turning it into offshore reality. So more pictures here. You can see on the most left, you see it inside the ATP hanging down, where it goes through the manhole inside of the monopile, where you can see the tool hanging and floating inside the water. In this picture it is horizontal, but usually we would go down vertically. And here's the whole control system we're using. And actually, fun fact, one of the client reps was able to put in the anode himself, so you don't need extensive training to be able to operate this tool. It's very user-friendly. So yeah, some pictures. If you like or require some more information on the actual installation and the first lessons learned, then our colleagues from Corrosion, our friends from Corrosion, and Peter Prince, my colleague in the front left here, is able to answer any questions you may have or require more information. And then my presentation comes to a closing. So looking ahead, there's still a lot of challenges to face and overcome in the market. But every innovation is starting with a challenge worth solving. So there's a lot of challenges coming up. If you're having any of these problems or challenges, then please feel free to reach out to us and the team. We're always happy to think along and work together on working on these solutions. And then my presentation comes to a close. So if you have any questions or anything related, then please come to us after the presentation, and then we'll provide a bit more information on that.